Hey everyone, this is Chris Dingman. I'm a math and science tutor and I specialize in SAT preparation. And this video is going to help you in any math class and specifically also for the SAT. And that is, the topic is functions. Functions is a fundamental topic in math once you get into high school, and a foundational understanding of it is important for doing well in the math section of the SAT. So I want to give you a really fundamental, solid knowledge of functions. Now I'm going to get into some more detailed real-world examples of functions in the next video, but I do want to say something up front right here before we talk about functions in general about why functions are there, why we have them at all, just so you have some sense of learning this for a reason beyond just learning it. Functions are all about things changing. So things are always changing around us, right? And things change because of other things. So for instance, if you put money in a bank account that gives you interest, then over time, your money is going to change. So time is changing, and that causes your money to change and go up because you're getting interest. So we'd say money is a function of time. Money depends on the time. And you're going to see that money would be called the dependent variable. We'll get into variables in a minute. And time would be called the independent. But let's not worry too much about that. My whole point here is that things change over time, or things change in general. Another example, the tides change. The tide goes up and down, so we could say the height of the water is changing, and that changes according to, let's say, the strength of the gravity from the moon. So the gravity is changing, the force of the gravity, and that's changing the height of the water. So we could say height is a function of the force of gravity. So in a nutshell, functions are about something changes and that causes something else to change. Now let's talk more about nuts and bolts of what you're going to be dealing with in a math class. Okay, a function is essentially a rule. It tells you something to do to a number. For example, the rule could be double the number. Okay, I'm telling you to multiply a number by 2. So we can think of a function as like a little machine that's inside a box, and you need to input some number into the box or the machine, and it's going to output another number according to the, you guessed it, the rule of that particular function. So the example I gave you was a function that multiplies a number by 2. So let's just put, for example, in there, times 2. Okay, so let's say we decide to input a 3. Boom, into the box it goes. What's going to come out? Well, 3 times 2 is 6, so we're outputting a 6. All right, now we could, of course, have more complicated functions. We could do more than just multiply by 2. We could add 6 and then divide by 7. All right, so then, of course, we would pick any number we felt like let's just say 4. Stick in a 4. We got to add 6 to that. We're going to get 10. And then the rule says divide by 7. 10 divided by 7, we'll just write it like that. That's what that fraction bar means, divided by. So 10 divided by 7, we can just say that's our answer, 10/7. So let me put that as our output. That's all there is to a function, okay? Input a number, apply the rule, output a number. Now, you could have a function that says leave the number alone. All right, I'm just going to riff a little bit on some other aspects of functions here while I have your attention. So, in other words, the function can just say input 8, output 8. That particular function is very simple. Leave the number alone. You could have a function that's even simpler than that. You could have one that it doesn't matter what you put in, it always outputs a 5. So, stick in an 8, you get a 5. Stick in negative 136, you get a 5. Stick in 0.0718, you get a 5. Now, here's what I want you to notice. Actually, before I say that, what you can't have, what a function can't do is give you options coming out the other end. Okay? You need to know in a function that if you put in a particular number, in this case 8, you know only one number you're going to get out, in this case 5. Okay? It doesn't matter if every number gives you a 5. What matters is if you put in an 8, you know you're going to get a 5. It's not a function if you put in an 8 and you sometimes get a 5 and sometimes get a, 11. You can't have choices coming out the back end. You have to have a certain output. So notice that with our doubling function, when we did times 2, that was a function because every time you put in a 3, it gives you a 6. And same with adding 4 and dividing by 7. There's always only one output for a particular input. Okay, now let's look at how functions are normally going to be shown to you in a math class or presented on the SAT, and that's with equations. When you have functions written as equations, you have a sort of a spot in the equation where you put the input and a spot where the output is going to appear. Okay, so those spots or places, let's call them places for the input and output, those are going to be variables. Okay, which means letters, X, Y, those are the most common, but you can have really any, W, R, etc. Why are they called variables? Because they vary or change. And that's absolutely necessary in any function. You've got to have a place to put the input, and that input can change. That's kind of the whole beauty of a function, is you can put different things in there. Okay, and then of course same for an output. That has to be a variable because that has to change depending on what input you put in. So how would a doubling function, the first one we mentioned, where the number is getting multiplied by 2, what would that look like? It would look like this. If I want to use y and x, you can use any letter. Don't get hung up on what letter you use. That doesn't matter at all. Y and x just happen to be the most common. They're kind of easy to draw. Boom, 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 boom. Okay, so, and this means 2 times x. When you just put a number next to a letter, it means multiply. So, this is saying I can put in any number here. X is the place for the input. It's the place I can put a number, right? So, for instance, we put a 3 in. In other words, all we're doing is substituting 3 for x. So it's 2 times 3. You can use a dot for times. And of course, we get y equals 6. So notice you inputted a 3 and you outputted a 6. What about that function where you just got out the number that you put in? That would look like this. Y equals x. You could call that one of the simplest functions. Well, it is the simplest function, I would say, if you're going to have two variables. So whatever we put in for x, whatever we input in that placeholder, let's say we put in a 17, substitute 17 for x, and you get y is 17. There's your output right there. Input of 17, output of 17. The number doesn't change. What about that one where I said you always get a 5? What does that look like? You would just write y equals 5. How simple is that? All I'm saying is the output is always 5. I don't even care what the input is. I didn't even give you a spot for an input. I just told you the output. It's always 5. All right, so that's that one. That's that function. All right, now let's talk about that more complicated one I gave you. I think it was add 4 and divide by 7. So that would look like this. Here's my input. I'm going to add 4 to it. Then I'm going to take that whole thing, that's the parentheses. We can do another lesson on parentheses and all that. So that whole thing I'm going to divide by 7, except it would normally, you'd use a fraction bar for division. X plus 4 divided by 7. That's going to equal your output. So that other function I gave you was this. It would be written that way as an equation. So remember, any function, well, actually, this is kind of an unusual one where you always get a 5. But any other function where the output can change, you're always going to have, and most of the functions you're going to see in math, you're always going to have a place to put the input, and it's always going to be a variable. And then you're also going to have an output place, and that's going to be a variable. Right? And then you're going to have other various operations and other numbers. Operations, I mean like adding, dividing, and you're going to have other numbers involved. So if I just threw some random other functions out there, I could say y equals, actually, let's make it a different variable this time, just to keep things fun. W equals 2t to the third power minus 6 all over 17 to the fourth plus 218. Okay? Just another random function that you'll never see again. So I want to leave you with this. I see this mistake that students make sometimes, fairly frequently, that shows a fundamental misconception about variables and what a function is. And the way you can avoid that and really see clearly is don't think of a variable, let's say, just in this example, don't think of these variables x and y, as fundamental features of this function. Like I'll hear kids say, "Oh, for this function x is 5." No, x could be 5, but x is not even really a thing. It's a place. Think of those variables as almost like a little cup or a tube. So let's say the fundamental features of this function is that 3 gets multiplied by something and then 2 gets added to it. And like I said, the x is like a place. It's a space to put any number you want. And then the y is, I'll make it like a little spigot. It's another space where some other number comes out. So if you can just remember that, you'll have a really good notion of functions, and that'll help you out a lot. Think of variables as places, and think of the other aspects of the function as what the function is. Right? So this function is multiply by 3 and add 2. Okay, so I think that's a good place to stop for this lesson. And in the next one, I'm going to talk about how functions are useful in the real world and all over the place in math and science. Okay, see you next time.